In this video, we are going to discuss a problem based on parallel plate capacitor. In this problem, one of the plate is given charge as Q1, Q2, and another plate is given charge Q3, Q4, and we have to find the potential difference between these two plates. I have seen the solutions on internet, but the answers are correct, but the explanations are not as satisfactorily as it should be. So I have decided to explain this problem. Now let us consider this parallel plate capacitor. Having charges on one face it is Q1, on another face it is Q2. Similarly on the second plate it is Q3 and Q4. Now if we take any point P on this plate within this conductor, any point P, so we know that the electric field inside the conductor has to be 0. So if we calculate electric field due to each charges, that is Q1, Q2, Q3 and Q4, and each phase will behave like a sheet and having an electric field given by sigma by 2 epsilon naught. So the first phase, suppose due to Q1, will have electric field in rightward direction. I have indicated rightward direction as positive and it is shown by this yellow line. Similarly for Q2 it is in positive x direction. Same way Q3 it is in positive x direction and in Q4 it is in negative x direction. So if we write net electric field at point P, then due to Q1 it is sigma 1 by 2 epsilon naught, where sigma 1 is your charge per unit area. Similarly for 2 it is positive, that is sigma 2 by 2 epsilon naught. For third it is sigma 2 by 2 epsilon naught, that is in positive x direction, and fourth it is in negative x direction, that is sigma magnitude is sigma 4 by 2 epsilon naught. If we substitute the value of sigma 1 as q1 by a, likewise q2 by a for sigma 2 and q3 by a for sigma 3 and q4 by a for sigma 4, we get this result: sigma 1 by 2 epsilon naught a plus sigma 2 by 2 epsilon naught a plus sigma 3 by 2 epsilon naught a minus, sorry, I have by mistake I have said sigma, it is q1. So q1 by 2 epsilon naught a plus q2 by 2 epsilon naught a plus q3 by 2 epsilon naught a minus q4 by 2 epsilon naught a equals to 0. So when we simplify it, we get a relation q1 plus q2 plus q3 minus q4 equals to 0. This is the relation between the charges q1, q2, q3 and q4. Now we have decided the direction. Now if we consider any point within these two plates, between these two plates we consider any point and we find the electric field. So electric field due to q1 will be in rightward direction, electric field due to q2 will be in rightward direction, electric field due to q3 will be in negative x direction or leftward direction, and electric field due to q4 will be in negative x direction. So when we write electric field, net electric field between these two plates, we obtain E equals to sigma 1 by 2 epsilon naught, because each plate is behaving like a sheet. So for first it is sigma 2 by epsilon naught, for second it is sigma 2 by 2 epsilon naught, for third it is in negative x direction, so minus sigma 3 by 2 epsilon naught, and for fourth again in negative x direction, so it is minus sigma 4 by 2 epsilon naught. When we put the value sigma 1 as q1 by a and sigma 2 by q2 by a, likewise we obtain electric field as q1 by 2 epsilon naught a plus q2 by 2 epsilon naught a minus q3 by 2 epsilon naught a minus q4 by 2 epsilon naught a. Now we have just calculated that q1 plus q2 plus q3 minus q4 equals to 0. This relation was obtained when we have calculated electric field at point P, and that has to be 0. So we obtained this relation. So we can say that q1 minus q4 equals to minus times q2 minus q3. This is from this relation q1 plus q2 plus q3 minus q4 equals to 0. Now rewriting this equation, that is E as this equation, we can say that q1 by 2 epsilon naught E is q1 by 2 epsilon naught minus q4 by 2 epsilon naught plus q2 by 2 epsilon naught A minus q3 by 2 epsilon naught A. And if we substitute this value, q1 minus q4 equals to minus times q2 minus q3. So we will obtain a relation E equals to minus Q2 by 2 epsilon naught A minus Q3 by 2 epsilon naught A plus Q2 by 2 epsilon naught A minus Q3 by 2 epsilon naught A. Here what I have done, I have substituted Q1 minus Q4 as Q minus times Q2 minus Q3. Now this value minus Q2 by 2 epsilon naught A and plus Q2 by 2 epsilon naught A will cancel out. So we will obtain net electric field as minus times Q3 by 2 epsilon naught A minus Q3 by 2 epsilon naught A. Now this is our parallel plate capacitor, and we have electric field in rightward direction. If we take a Gaussian surface, this green box is our Gaussian surface. So what we will observe that there is no electric field within this conductor, the second conductor, and there is no electric field within this conductor. So if we calculate the electric flux, net electric field is in positive x direction, so electric flux through the upper surface will be 0. Similarly, through the downward surface will also be 0 because E and ds are mutually perpendicular. E dot ds is 0. Similarly, on this surface it is 0, and similarly on another surface that is 0. And on this surface, since on this surface I am talking about this surface, so on this surface electric field is 0, so there is no electric flux. Similarly, on this surface electric field is 0, so there will be no electric flux. So net electric flux through this box is 0, and total charge enclosed is Q2 plus Q3. So Q2 plus Q3 will be 0, so we can write Q3 equals to minus times Q2. Now we have obtained net electric field between the parallel plate capacitor as minus Q3 by 2 epsilon naught A minus Q3 by 2 epsilon naught A. So we can write potential difference between these two plates as E dot ds, that is, in terms of magnitude we can write it as E into d, because E and d are in same direction, so we simply multiply. It is like a scalar multiplication. So this value turns out to be minus 2q3d divided by 2 epsilon naught A. I have multiplied this value with d, and now we have a relation Q3 equals to minus times Q2, that is from the Gaussian surface which we have obtained just now. So we can write Q2 minus Q3 equals to minus Q3 minus Q3. I have substituted just the value of Q2 as minus Q3. So the potential difference can be written as minus 2q3d divided by 2 epsilon naught A. So now this 2q3 is Q2 minus Q3. So I have substituted this value minus 2q3 as Q2 minus Q3. So the potential difference is Q2 minus Q3 into d divided by 2 epsilon naught A. So finally we have V equals to Q2 minus Q3 into d divided by 2 epsilon naught A. That is the potential difference between the plates. Now we know that the capacitance is given and it is pure geometric consideration. So C is epsilon naught A by d for this parallel plate capacitor. So we can write V as Q2 minus Q3 divided by 2 epsilon naught A in divided by d. Now this value is our capacitance C, this value epsilon naught A into d. So we can write it as V equals to Q2 minus Q3 divided by 2C. Thank you.